Okay, the clock just ticked over to 3 o'clock. So welcome to the third week of the UF Department of Geography's Colloquium series. The speaker today is me. I took the prerogative of the Colloquium organizer to go ahead and let myself talk to you. You see the slide here, the flyer in front of you. I'm going to try to do something today that's most people don't do, and probably with good reason, but we'll find out how well it's going to work out. I'm going to talk about three different things. I'll get to that in a few minutes. Before that, in the usual introduction, though, I have to say, I've been professor of geography at the University of Florida since 1997. You can do the arithmetic, it's a long time. I'm as old as dirt. I have a BS in biology from Kansas State University, a Master of Science in Fisheries from Louisiana State University, as several other alums of LSU in the department, and a PhD in biology from Indiana University, which again, we have several other people in the department who graduated from there one way or another. I am interested in something called Macrosystems Biogeography. Nobody really knows what that means. Nonetheless, I'll get away and take it away with the presentation that I put together about working at the National Science Foundation. Can you see the slide and not the notes page?
Yes, we see it.
Thank you. Working at the National Science Foundation, and something about the program that I directed, along with another couple people, called Macrosystems Biology and Neon-Enabled Science. And then, if I have time at the end, maybe I won't, if I'm lucky I won't, I'll talk to you about a macrosystems biology project that I've been carrying out in conjunction with a bunch of collaborators. Now, to set the stage, in July of 2017, I went to the National Science Foundation for 2 years to serve as something called a rotating program director. I was department chair from 2011 to 2016. Then I had a year of research assignment. So I was not around the department for about 3 years. Those 3 years have seen some of the most profound transformation in the department in anybody's memories, for that matter, in the history of the department. We've grown enormously. We put a whole lot more faculty in, a few people retired. It's a new place. Well, because it's a new place, and because I've been able to share some of my experiences with only a few of you, I decided to tell you today a bit of a personal memoir of a career turn that many people don't do. But if they do, they find it incredibly rewarding. And maybe you'll learn something from me. I hope you'll find it useful in the sense that it might give you some insights into a federal agency to whom many of us apply for funding for our research. You might find it intriguing as a potential segment of your own academic career. And you might find that the programs about which I'm going to talk might have some research opportunities for you. So I was one of 2 directors of the Macrosystems Biology and Neon-Enabled Science program. I worked at NSF on the program team supervising the National Ecological Observatory Network, or NEON, and I participated in various working groups while at NSF. Now you might be interested in what it's like to work at a place like NSF, what the programs are, and see a brief example. I'll do my best not to make this an old geezer's war stories, but instead inform you about a major institution in our world and some of the really fantastic things that it does, and illustrating it by only one tiny piece of my own research. Well, just the slide, talk about this. This is the new NSF building in the, let me put the laser pointer on. There's a new NSF building in Alexandria. When I first went up there for 2 months, it was in Arlington. I commuted from Alexandria to Arlington on the metro. Here I am, a picture made by my wife, Leslie Newman, outside NSF on essentially the last day that I was there, getting ready to leave, wearing GeoGator swag and doing the gator chomp. Okay, what I'm going to talk about, this is the outline of the talk today. What it's like to work at NSF, those kinds of things. What did I do? How did I learn? How did I get there? What is NSF? Then I want to talk about macrosystems biology and neon-enabled science. Again, what it is, what's neon, and what successful projects have been funded by it. And then, if I have time, I'll talk a little bit about a project that I've been doing and then wrap it up at the end. Okay, so what's the National Science Foundation? Again, this is a place that many of us apply, write proposals to apply for funding to support our research. It's an independent federal government agency. means it's not in any of the departments. It's not Department of Commerce. It's not Department of Homeland Security, anything like that. The director of NSF reports directly to the president, well, through the Office of Science and Technology Policy. By the way, the chief science advisor right now is a guy named Kelvin Drogemeyer, who's a meteorologist. He's interested in extreme weather and numerical weather prediction. Sound familiar? Should. Okay. The basic function of NSF is indeed to give money to support the best possible research. But I'll also suggest to you that it's the most effective and amazing institution of any sort in the world. It's probably it's the only institution that funds the kinds of research that it does. And I'll tell you a little bit about it and what it's like to work there. Now, this goes all the way back to 1950. It goes back before that. During World War II, there was a guy named Vannevar Bush. He was an MIT professor, a dean and vice president of MIT, and then he became president of the Carnegie Institute of Washington. But then during World War II, they brought him into the government, and he headed the US Office of Scientific Research and Development, through which almost all wartime military research and development was carried out. In fact, he was the first presidential science advisor. He wrote a report to President Truman in 1945, the title of which was Science, the Endless Frontier. It made the argument that there should be a government agency that would support basic science in all sciences except for human health, which had its own funders, to provide the foundation for future prosperity of the United States. The Congress and the President agreed, and the National Science Foundation was actually founded in 1950. This year, they're celebrating their 70th anniversary. The fiscal year budget for 2020, which is just now coming to an end, is $8.3 billion. That sounds like a lot of money to us, but when you spread out over all the universities and all the researchers in the country, it turns out not to be so much. It's also about half the cost of a single aircraft carrier, its construction, operation, and maintenance. So double the annual NSF budget and you get an aircraft carrier. It continues to fund basic research, fundamental research in all areas of science, mathematics, and engineering. And again, I'll suggest that it's the most successful agency of its kind in the world. My office is right there where that red arrow is, from the 12th floor over towards the southwestern corner. I had a great view of the southern beltway around Washington, D.C. And there I am, again, the picture of me leaving NSF, taken by Leslie. Okay, NSF describes itself as the only federal agency whose mission includes support for all fields of fundamental science and engineering except for human health services. Nobody else routinely funds the kinds of things that NSF does. NSF's job is to determine where the frontiers are, who the pioneers in those fields are, and provide money and equipment to help them continue. The people who work for the NSF are incredibly dedicated, I found. They're very intelligent scientists and engineers who have decided to take a career track that helps other people carry out their research goals. And in doing so, though, they can actually shape the future of research and science in the US. Oh no, an org chart. What's this about? This is a bureaucracy, but who cares about the organization chart? Actually, I think that you all should care about the organization chart because NSF is organized in a way that is familiar to you but has different names. It's actually how the foundation is organized, how it operates. If this were a university, the director would be the president. The NSB, the National Science Board, would be the board of trustees. The assistant directors who are assistant to the director would be the deans. So each of the directorates is sort of like a college. Now their budgets are much, much larger than a college is. You know, maybe Pete can confirm this, but the College of Liberal Arts and Science budget is about $100 million a year. Well, a couple of programs within one of our divisions had a budget of about that much. So we're, you know, this in the divisions which are parts of directorates are like the departments. Now, there are 26 very distinguished sciences on the National Science Board. Our president, Kent Fox, is on the National Science Board. And an old friend that several of us know, Emilio Moran, of all people, is on the National Science Board. I've put the budget numbers in millions of dollars for each of the different directorates along this line, you can see that I was in the Directorate for Biological Sciences, which doesn't have one of the larger budgets, but it's got a fairly substantial budget. While I was there, there were two other geographers who were program officers in the division, the Director for Biological Sciences. Kind of interesting. The Director for Geosciences, which funds geology and atmospheric sciences and a number of other things, oceanography. The Assistant Director, the Dean of it, essentially, is a geographer, Bill Easterling from Penn State. He'd been Dean up there too. And of course, the program that many of us know about, which used to be called Geography and Spatial Sciences, and now is called Human Environment and Geographical Sciences, is in the Directorate for Social, Behavioral, and Economic Sciences. I'm going to suggest, though, that geographers have access to money from to funding from any of these directorates, first of all. Secondly, I know of geographers who have been funded through geosciences, and in my own program, Macrosystems Biology, there are half a dozen geographers who have been funded to do their research. So it's not a matter of, if you're a biologist, you get money from biology and so on and so forth. We even have geographers as program officers in these. Okay, another org chart. Yeah, what's he doing? Well, this is actually the Director for Biological Sciences in the structure of bio. Now, I was in the department or the Division of Biological Infrastructure, which includes human resources. They have postdoctoral fellowships. They have research for undergraduate experiences. They have RU sites and things like that. They also have research resources, which includes biological cyber infrastructure, collections in museums that they support, field stations they support, and major research instrumentation programs that they support. But I work closely with a bunch of people from the Division of Environmental Biology, which has these programs, in the program of Macrosystems Biology and Neon-Enabled Science. Now I have this dotted line going up to this funky thing called Emerging Frontiers. When I first went there, Macrosystems Biology was part of an Emerging Frontiers that was done in the director's office. This is a bunch of bureaucratic gobbledygook, but the money came from somewhere else. It's been moved now to be jointly managed between DBI and DEB. Now, you'll notice that I'll probably talk in acronyms a lot. One of the first things you learn when you go to NSF, it's a federal agency, is you can express ideas with acronym, acronym, verb, acronym, acronym, and everybody will know what you're talking about. Now, one other thing about this, I said something a few minutes ago about temporary program officers. Half of the program officers in biology, in the biological sciences, were temporary. They were called rotators. The other half were permanent, long-term career NSF people. They bring in people from research institutions, from other kind of educational institutions to serve for a couple of years, to bring new ideas in, to bring new expertise in. And then the people go back to their institution, as I did. There are a couple of different ways to come as in temporary assignment to NSF. One is as an Interagency Personnel Act, or IPA. Thank goodness they kept that acronym. Where you remain an employee of your home institution and you retain your benefits, my health insurance stayed active and all that kind of stuff. NSF awarded the funds to support my salary and fringe benefits. So I effectively had a grant at University of Florida to go live and work in Alexandria. There's an alternative version called the Visiting Scientist, Engineer, and Educator. You actually become an NSF employee and the salary is paid directly from federal funds. Now I show you this so that someday one of you, one of our faculty members, one of the grad students who may get a faculty job later on, somewhere in the early mid-career stage, you might have an opportunity to go to NSF to be a program officer. We'll talk about how I got there right before that. And there are all kinds of options and ways to do it. One of the things that option makes it really kind of attractive is that the NSF doesn't want rotators or permanent employees to lose sight of their research programs. So they actually provide something called the Individual Research and Development Program, or IRD. They give you basically, they support 3 days a year, basically a day a week, which is more than I got when I was department chair, to carry out your research, to continue your research program. In my case, the funding was mostly for travel. One of my colleagues used his IRD to earn a master's degree in project management, which serves him in good stead. He now runs the National Ecological Observatory Network program. As an IPA or as a rotator, I couldn't accept funds from NSF awards because it would be seen as a conflict of interest. But NSF could fund the research. So they sent me actually for 10 days in December of 2017 to work with my colleagues on field work in Cambodia. They sent me to some training operations. They sent me to conferences. They sent me to some other things that mostly traveled. It had to do with my research, even though it was back in Florida. So you have opportunities to keep things going. Okay, the main thing that NSF does, though, is to fund fundamental research in all sciences. They decide what to fund through what they call the merit review system. This diagram shows the workflow of the merit review system. Many of you are familiar with parts of this, but not all of it. We may have an announcement of an opportunity, which is a solicitation may be published that says, we solicit proposals to study this, that, or the other thing. They're done usually in fairly general description, and then they ask for the good ideas to come in. The communities then write proposals, submit them through FastLane or through research.gov, and then they go to the program officers. Now, my job as a program officer was to carry out the things in this red box. All the program officers do this stuff. You know, we do some of the compliance checking. We arrange for reviews through ad hoc reviewers. We arrange for panels. We put combinations of panels and ad hoc reviews together. Some proposals come in are small enough that they can be reviewed internally, so we ask other program officers to review them. Everything gets reviewed by other people, by third parties and fourth parties and fifth parties. Then we take those reviews, and this was the really part of the job that nobody sees from NSF. Many of you, have served on panels. Many more of you have probably written ad hoc reviews for different programs. But very few of you see what happens to those things. If you're on a panel, you write a panel summary. Write the panel summary. The program officer takes those panel summaries and the reviews and knows about and his or her own expertise and evaluates the proposal and writes a review analysis that determines that recommends whether the proposal should be declined, should be awarded, or what, and then has to make that argument to the hires up and then to the business side of NSF. Now, the merit review system is governed, as is all part things with proposals, by this document here. This is the cover of something called the Proposal and Award Policies and Procedures Guide, the PAPG. Now, PAPG is like a syllabus. You should read it. It's really boring in a lot of places, but it's really interesting in a lot of other places. You know, we all get annoyed as professors when students don't read the syllabus. You know, you can download a copy of the PDF file. We have a question about your proposal. You can look it up in the PAPG. Almost always you put it up in the PAPG. If you can't figure out something from the PAPG or the program solicitation, that's when you call the program officer. Okay. Okay, this is again the same thing from the PAPG. The merit review system has two major review criteria, so-called intellectual merit, which is the potential to advance science, and broader impact, the potential to benefit society. Okay, these are broad. Who decides? Who decides whether about the potential? Who decides about to advance science and benefit society? Again, we go back to the ad hoc reviewers, the panels, the combination of the two, and internal reviews that then analyzed by the program officer, who writes a review analysis that then sends it to the division director, who concurs, and then it goes up. If it's to be an award, it goes to the business side, which sends the money to the organization. If it's a decline, it goes right to the organization. Say, oh, sorry, we're not going to do it. Pretty simple, huh? Is that a question out there somewhere? Kate, you should probably turn off your sound. Anyway, NSF takes this very seriously. They have more detailed guidelines that come along in the PAPG. And I won't belabor, this second here, I've got it. Okay, I won't belabor this because every time that you're asked to review a proposal or asked to sit on a panel, they give you these guidelines. And these guidelines then are how you go through, read a proposal and determine whether or not it's a good proposal or a really great proposal or anything else. They also take conflicts of interest very seriously. You're not allowed to review proposals of any of your former PhD students or your former advisors. You're not allowed to review proposals of anybody from your institution. You're not allowed to review proposals from institutions that may be recruiting you for a position. There are a whole long list of conflicts of interest that we follow through and make sure that people are aware of, so we don't run into a conflict of interest. This creates the most level playing field for proposers possible. The conflicts of interest are taken very seriously. Every division has a conflicts officer who's deeply educated in the law and the practice of conflicts of interest, federal laws, and NSF policy. Now, all this works out. In the end, you get your grant or you don't. If you get your grant, you go out and you do great things. You write papers, you put data in repositories, you have broader impacts where you have PhD students, you change society a little bit. But actually NSF has, that's a little bit, sounds a little bit facetious, but NSF has had some extraordinary success stories, spectacular successes. NSF has had roles in your life that you don't know about. Of course, NSF maintains a list of all the extraordinary success stories, many, many pages in it. One of the first ones here is that Google came from NSF research originally. Larry Page and Sergey Brin were the two founders of Google. Larry Page was funded as a graduate student by the Stanford Digital Libraries Project, which is an NSF award to professors at Stanford. One of his colleagues was Sergey Brin, who was another Stanford grad student working on the project, but Brin was supported by a National Science Foundation graduate student fellowship. They concocted an internet search engine, the very first, well, it wasn't the first, there were others, Gopher and things like that, but an internet search engine that was based on the number of times a page linked to your page to determine the value of the page. They built a prototype, the hardware and software, in their student offices at Stanford, being supported, the equipment for the prototype and thinking was supported by National Science Foundation. Now, when I was an insider at NSF, I could look at reports, I could look at proposals and stuff like that. And I finally decided one day, even though it was a little out of school, I'd look at the last report of the Digital Libraries Project. And on the last page of the last report from the Digital Libraries Project, there's a question that NSF asks: what is the impact on society beyond science and technology? And there was a single sentence in that report. A private company, Google, was founded. Pretty remarkable. Smartphones. I've heard people at NSF say that every single component in your smartphone, whether it's an Apple or an Android phone, is based on some research that was done at NSF at some time in the past. Nanotechnology hardly existed until NSF funded a number of projects about 20 years ago with the nanotechnology. The internet. Well, Al Gore may not have invented the internet, but he did write some of the laws that enabled it. But before that even, NSF took the internet over from the Defense Advanced Research Projects Administration, which actually had begun to invent it in the first place, took it over for 10 years, from about 1986 to 1995. They supported research that led to something called packet switching, which is how the internet works now. They ran NSFNet. It was the prototype internet for 10 years, starting at 85. They mandated that the TCP/IP protocols be required for use of NSFNet. This is mostly for educational and research organizations, which made the internet possible. That's what we know today. We still use TCP/IP and they still use packet switching. And that was all supported by NSF-supported research. NSF role ended in 1995. It transferred to regional networks, commercial networks, as the private sector became more interested. This is the thing that we see happening over and over and over again, is there'll be research that's done, that's supported by NSF, that will create the basis of something that then will be commercialized. The commercial interest, the private sector has no interest in some of these early steps of research at all, because they don't give a return. They're only interested when they can be commercialized. And in fact, the government, let me say it this way, never believe that the government cannot create wealth. You hear that from a lot of sectors. The Bayh-Dole Act, Birch Bayh of Indiana and Bob Dole of Kansas, a liberal and a conservative, got together, wrote an act, was passed, signed by the president, that allows recipients of federal research money to commercialize their products. Universities and individuals now have large incomes from the patents and companies because of this. You know, I even own a few shares of Google stock. I'm not wealthy, but the government actually set the stage to create the wealth. Other things, Doppler radar, that's the kind of things that Dr. Matthias and her students use all the time. That started as a project supported by NSF. American Sign Language was created through research projects from NSF. Magnetic resonance imaging. Actually, right now, the University of Florida and Florida State are the National High Field Magnetic Laboratory supported by NSF, who are advancing MRI activities all the time. Then the most really interesting one, because there was a project a number of years ago, several people were looking at thermophilic fungi, fungi that live in the hot springs of Yellowstone National Park. They thought, this is a pure science thing. Who cares about thermophilic fungi? Well, about the same time, somebody invented polymerase chain reaction, which is the reaction that amplifies DNA and gives you, 55-gallon drums full of DNA so you can do analysis on it. Well, it turned out that PCR, polymerase chain reaction, requires enzymes that function at very high temperatures. And it just turns out that the same enzymes that were found in thermophilic fungi now are used in PCR. So, wild and crazy fundamental research project has now given us the ability to do all the DNA analysis that we need to do. Okay, so how did I get this job that was with this fabulous federal agency? Over the years, I've written dozens of proposals to NSF. A few of them have been successful. The highest batting average that we could find was about 60%, and I'm nowhere near that. And because I got on the radar by the program officers and having submitted proposals, and they knew my area of expertise, they started to ask me to write ad hoc reviews of the proposals, of other proposals. So I started writing ad hoc reviews. Now, finding referees is a large part of a National Science Foundation program officer's job. Who's qualified? Who can do it? If you are asked because they've started to know you, one thing, you can also send an email to a program that you might like to review for and say, I would love to be on your list of reviewers. Then they'll start to ask you to review, and you tell them your expertise, then they'll start to ask you to do reviews. Now, one word of warning, they'll ask you to do a review. You should say yes or no immediately. If saying no doesn't count against you. You might have all kinds of other things going on. But if you say nothing, it's considered a yes, and it counts as a requested review unfulfilled later on. So say yes or no immediately. Well, I had no idea whether my reviews were useful. I just tried to make sense of each proposal and evaluate it honestly. So I got asked to serve on a panel, which was pretty cool. But my first panel meeting was a disaster. I had no idea what was going on. A bunch of people in the room shouting at each other and bewildered by the chaos in the panel room and required to write panel summaries. Got past it and did okay and kept being asked back. I ended up serving on 3 different macrosystems biology panels before I went up as a program officer. And I had a phone call one day in November of 2016, or not a phone call, I had an email first from the program officer of my Macrosystems Biology grant. And I thought, oh my God, what have I done wrong? I better call Liz Blood, who's her name. I better call Liz and see what I've done wrong here. So I called her and she said, we'd like to invite you up to interview for being program officer for Macrosystems Biology. The current program officer is leaving at the end of the year. He's a rotator, and we'd like you to come up and do this. So I did. Said, sure. Talked to Jane a little bit and said, what do you think about doing this? She said, great idea. So I went up, interviewed, and they basically hired me. I was flabbergasted with the phone call. But on the other hand, my career situation and my family situation was congenial. I was seeing Leslie Newman, who's now my wife. We talked to each other about going up, and we decided, yeah, I should go up there, and then we would visit each other on weekends and enjoy Washington, D.C. Offered the job, so I took it. But it started by submitting proposals, becoming known to the program officers. You could send an email to them saying you'd like to review for them. That works. Then being asked to serve on panels. And finally, after you've done that for a while, they'll recognize you as someone who can come up and be a program officer. So what happened at NSF? Well, I have to say, National Science Foundation has enormously effective onboarding and training early in a program officer's career. We went to the program director's boot camp for 3 days. We had merit review basics for 4 days where we learned how NSF does things. We already were familiar with writing reviews. We're already familiar with writing and evaluating proposals. But NSF's way of writing review analyses and handling situations was important there. They trained us on multiple data and analytical systems. We could go into the databases and see how many awards had been made and all kinds of stuff. I made deeper dives into software than I've ever done before. I now know things in PowerPoint and Excel and some of the linguistic analysis, even some GIS tricks that I had no clue existed beforehand. Went to a huge number of meetings. They were surprisingly productive. A meeting had an objective every single time. You have a meeting agenda with the objective stated. We have to do this by the end of the meeting, and you don't leave until you've done it, and you always get it done in an hour. I wrote several solicitations with teams. I wrote Macrosystems Biology solicitations. I wrote a solicitation with Jim Jones, who was from the University of Florida. Many of you know him, about signals in the soils. I had a hand in the mid-scale research instrumentation solicitation and the Biology Integration Institutes. Served on working groups. I got sent to national conferences to talk about NSF programs. One of the favorite things that I would do is consult with potential principal investigators about their ideas for proposals. They'd send me a one-page prospectus, call me up a few days later, and we'd talk about whether it was appropriate for our program or other ideas. And then I could coach them in how to make their proposals really good. We received the proposals, checked for compliance with the solicitation. We solicited co-review with other programs at the foundation. When you send a proposal to a program, there's a good chance that if it's a broad proposal, that they may ask for other programs to come co-review it and help co-fund it if it's a successful proposal. Now that may sound to you like double jeopardy. It's not. It turns out that there's no relationship between the number of programs that co-review proposals and the proportion of them that get funded. In fact, almost all of my proposals over the years were co-reviewed by multiple programs, and it seemed that the more programs looked at, the more likely it was to be funded. So that's a possibility. We formed panels by inviting people with relevant expertise to serve. We had a long list of potential panelists, and we would email them and ask them to come serve if the proposals that had come in needed their expertise. We put together the panel meeting. This is kind of what it looks like, although none of the people in my program ever wore suits and ties. Including, we have a panel dinner, a great social event one evening. Panel summaries are written during the panel meeting, and we have to approve the panel summaries. After the panel is over, you would analyze the panel results, and analyze the reviews, and write a review analysis for every single proposal, whether it's a decline or an award. You justify the decision. It's a recommendation, and other people make the final decision. Also managed awards. I check the spending. NSF has a way to look at the University of Florida's accounting system and tell how your grant is moving along, how your award is being spent. We approve reports, we considered and approved supplements, no-cost extensions, and rebudgeting. We also, and this is on the lighter side, attended mentoring sessions every Wednesday starting at 4 p.m. Now the time of day might give you a clue. This was happy hour. But it was also one of the most important times, a couple hours that most of us would spend. Program officers come in with all kinds of outside knowledge, but they don't know what's going on inside. So we'd all go over to Foster's Bar and Grill, anywhere from 6 to 20 of us, and sit around and talk about what was going on, questions we had. One day, a woman sat next to me, and we started drinking beer and talking to each other, and she introduced herself as Jean Feldman. And a little while later in our conversation, I started criticizing something up in the PAPG. It was really ambiguous about international activities. And the guy across the table from his face went white. And I said, "What's wrong?" He looked at me and said, "Jean Feldman sitting next to you is the author of the PAPG." And she looked at me and she said, "Mike, maybe it's ambiguous for a reason." So I got to know the person who writes the PAPG. Other people had that opportunity too. And Leslie and I enjoyed the DC area cultural amenities immensely. This is the East Building of the National Gallery of Art with the Calder statue and some just absolutely wonderful art in it. And then every night, after a long day of work, of intellectual effort, I'd go back home to my little apartment. I'd sit down in my chair, just completely intellectually exhausted. What did I learn at NSF? I learned what makes a proposal a good proposal. I learned how complicated the operation of a large facility can be. It has to have a program management education experience. I also learned that, something I said already, NSF employees are extremely intelligent. All the program officers have PhDs in the first place. They're dedicated scientists. They have decided to take a career path, though, that is involved with providing support to others in a critical way. And in doing so, they actually shape, with the writing solicitations, they shape the direction of research in their field. My program, Macrosystems Biology, was basically created back in 2009 by Todd Crowell, who's now a professor at Florida International, by Henry Gulls, who was a permanent program officer, but he was a forestry professor at the University of Florida for many years before he went to NSF. Henry tragically died in a rock climbing accident in October of 2017. And Liz Blood. 3 people put together Macrosystems. And in doing so, they've really, I'll talk about that in a few minutes, they've really changed the way that we look at environmental systems now. I also learned that when you work at a federal agency, you have a boss. Professors have nominal bosses, but they don't always tell us what to do. We always feel like we're independent. At NSF, you're allowed to do things and you're not allowed to do things. One of the first things my division director told me was, "You're a professor, you're accustomed to getting forgiveness instead of asking for permission. You can't do that here. You have to ask permission for everything." So I learned how to do that. And finally, NSF takes very seriously the conflicts of interest and attention to federal laws. It's a federal agency, it has to. In every division has a conflicts officer who's trained. Okay, I'm not going to belabor this too much because I want to get on to talk about macrosystems, and I'm running low on time, which I knew I was going to do, but that's okay. Okay, what can you do to make sure you have a good proposal? You focus on the ideas. You don't focus on the location, the system, the species, the tools, the policy context, or end applications. You have to ask a sharply defined research question. You have to derive testable hypothesis logically derived from the theory that addresses the research questions. And you have to come up with methods that test the hypotheses. It's strictly hypothetical deductive science. This is the case in biology, less a case in the social and behavioral sciences, but still, if you do those things, then you're a long ways toward making your proposal really compelling. Now, if you're working in, I said, your place is an important theme in geography. I said, don't think about don't focus on the location as something you're studying. For example, if you're working in the Amazon basin, tell us what about your research will give us new knowledge about human-environment interactions, or new knowledge about political ecology of way people interact with nature and with each other. Not what's happening in the Amazon. Give us the general takeaway from it, not, well, the Amazon does this, the Amazon does that. Now, I know we have people working in the Amazon who do a good job of that. Okay? Now, the final thing, you can read some of these other things in here, most of it's more or less kind of bureaucratic and boilerplate, is tie your activities in your proposal to your budget. Each budget item must have a reason for it to be there, whether it's field work or an instrument you need or interviews with people or whatever. It has to be tied back to the budget. That's really important. Okay, shifting gears, it's 3:39, so I'll have just a few minutes to talk about this. Talk about another 5 minutes or so, is macrosystems biology and neon-enabled science. Now this is the solicitation that over here of the program that I managed for 2 years. There's my name right down there too. It's an older solicitation that Dan Gruner and I wrote. It's been supplanted by a newer one that I'm not on. I'm not a cognizant program officer on it, but I was on the writing team for it. And as with the PAPG, remember the basic grant guide, program officers get a little annoyed when people don't read the solicitation. Almost all the questions about the program can be answered by reading the solicitation. We used to send notes back to potential PIs who would ask us questions, emails about the solicitation with quotes from the solicitation. Well, according to the solicitation, X, Y, and Z. It's just like students not reading the syllabus. Okay, I'm going to talk about in the next few slides both macrosystems biology and neon-enabled science and neon. And then I'll probably run out of time. I'll try to show some of the awards. Well, let's see if I can get this thing going. Well, this is supposed to be an animation, but it's not animating, so I'm not going to worry about it. What it shows is the seasonal cycle of greening up and browning down, the snow coming down, the fires erupting in all kinds of different places. This is the subject of macrosystem biology. Now, human perceptions of nature are biased. We understand best those things that are about our size or that we can see in one view. Microscopes showed us smaller things. Air travel, when we're looking down at the ground, and satellite remote sensing have shown us much larger things. But we're only beginning to understand them. Now, this map is a MODIS map of a remote sensing variable called normalized difference vegetation index. And again, because you can't see the animation, which we're not going to worry about, can't see how, so, but it does change over time. Seasonal changes in light, water availability, phenological matches and mismatches, fire frequency, biogeochemical changes, especially carbon cycle right now. Greening is carbon uptake by the vegetation, browning is carbon release to the atmosphere. All interact to drive the spatio-temporal pattern. Now, if you have a basic physical geography class, you know what drives the broad brush patterns here, the warming and the cooling and the greening. But there are billions and billions of organisms in that image that are causing and experience the annual pattern. There are untold trillions of microbes. Plus, there are about 400 million humans in the view. You can't see them either at this scale. On the other hand, you can see light spots like here and here and here and all the way down here in South Florida. The only species that even has a trace of something you can see in this image is human, from the clearing around cities and things like that. Okay, so the main question of macrosystems is, how does environmental variation interact with organisms to produce patterns that we see at this continental scale? Why is that important? Because many of the environmental issues that we face are continental in scale: climate change, migratory animals, and stuff like that. Ecologists and geographers are increasingly confronted by questions that involve analysis or prediction across vast geographic areas and long time periods. Okay, here's just several of them. They're all spatially heterogeneous, okay, which is the stock in trade of geography, spatial heterogeneity, differences between locations, things like that. But that also implies that a study at any one site or even several sites will not give us the broad picture that we must have to understand the biological effects and to manage them, especially the largest issue of all, climate change. Again, the vulnerability to climate change is shown here. Okay, bunch of words, but this is the solicitation macrosystems biology principle. They're macrosystems interested in funding quantitative, interdisciplinary, systems-oriented research, biosphere processes and their interactions, and regional to continental scales. There's a second stage, training and activities to broaden participation of researchers. And then the point about you can't extrapolate from a single point. And we want people to develop new conceptual framework, contribute to theory, do empirical studies, syntheses, even predict and forecast ecological change. That's right out of our solicitation. people have taken that and done a lot of work over the years. Remember, the first of these things was in 2010, so it's been only around for 10 years. And they've come up with this. The main principles, the theory of macrosystem biology are about cross-scale interactions, variation within and among regions, teleconnections and coupled systems, emergent phenomena. Of course, then there are a couple of ways of doing things, but the use of national scale data sets, including NEON and SIRGO, and national land cover data set. Geographers are accustomed to using data sets that have already been provided for them. And here's kind of a theoretical diagram. And there's some actual cases of interesting processes that are going on at different levels. Okay. Now, this is from a paper by Heffernan et al. In 2014 that points out the scale variation. Farmers in the Midwest had planted lots of crops that geese ate a lot of and multiplied rapidly and much more productively than usual. They then flew to Hudson Bay where they wiped out the wetlands, basically. So this is teleconnections, one thing, Midwestern farms to Hudson Bay. It's also cross-scale. Each individual farmer made a decision to plant something. The geese came down there and then they went up there and they wiped out most of the wetlands to the west of Hudson Bay. Sullivan in 1992 said the problem of across scales is central in biology and all of science, critical. Okay, I'm going to basically stop there. I'm not going to get to NEON. I'm not going to get to any specific things about macrosystems biology, but I can answer some questions. I've got 5 minutes to answer some questions about NSF and about being up there and how kinds of things went on. One thing I'll say before I go to that is that one of the reasons that NSF is favored by Congress is that it gets money into nearly every jurisdiction in the United States and reports the awards to the congressional representatives. They love it when we make a $200,000 award to the University of Florida. Florida has had 7 macrosystems awards, including 4 here at the University of Florida and 1 each at Florida State, University of South Florida, and Florida International. Okay, so I'll leave it with NEON and open the floor for any questions that you may have. No questions. I'm going to go through a bunch of these.
I have a question, Mike.
Sure, Katie.
What do you think was one of the most challenging things, either about transitioning to working at the NSF or transitioning back into a more regular academic setting?
I don't feel like I had much of a challenge going to NSF. It turned out when we went through the training and I started doing the job, and I realized any professor, any faculty member, associate professor, even assistant professor is pre-adapted to do this job. You know, we've been writing, we've been evaluating people's work, we've been writing proposals, we've been on panels, so you go into it, once you learn the few ways that NSF does it, not such a bad deal. Now, I'll say that coming back has been a bit of a transition. The pace slows enormously. You're learning new things every day at NSF. You're on the hook for all kinds of deadlines coming up all the time, and you're constantly working. At the same time, they expect you to carry out a nice work-life balance. They don't expect you to work on weekends. They don't expect you to work at night. You're expected to work 8 hours a day, to work your butt off 8 hours a day, and you do. And it's great stimulus. But coming back, it's okay, now I'm in charge of my own schedule. Now I'm in charge of getting around to writing the paper I was supposed to write with no deadline. Now it's the class starts, and that's about the only deadline we have. So yeah, that's a good question, an interesting one. Growing up, great time, all kinds of anticipation. Coming back, whoa. Well, this is the synthesis that I had. Fascinating, wonderful every day, learned an enormous amount. Our program, I didn't invent it, but I continued it, argued for it. Changing the way of ecology, environmental science, and even some geography view the world. I didn't get to show the slides of projects that have geographers on. Later on in the semester, Stephanie Powell from Florida State will give a talk. She has a Macrosystems award that we gave her and her team a couple of years ago. Kyla Dolan at Michigan State is a geographer. Kendra McLaughlin at Kansas State is a geographer, was a program officer with me up at NSF for a while. Geographers are moving into, it's a convergence of biology and geography. Neon and I didn't get a chance to talk about, and we don't know about the outcome of my research. That's it. Any other questions while we're here? I'm drinking water out of my NSF cup. Well, Mike, you want to call it quits? I'll stick around for another couple minutes in case somebody has any question after.